Welcome to Mod 2 of this data science course, where we'll be looking into data collection and processing under the following units: data sources, structured versus unstructured data, data cleaning and preprocessing, and introduction to tools such as Python, Pandas, and NumPy. Data sources, structured versus unstructured data. Brief overview of data sources. Data, the raw material for data sciences, originate from countless sources and exist in various forms. Understanding the fundamental type of data is essential for collection and processing. The two primary categories are structured and unstructured data. Structured data. This type of data is highly organized and conforms to a predefined format, typically residing in tables within relational databases or spreadsheets. It consists of clearly defined data types like numbers, short text strings, and dates, arrays in rows and columns because of its organization. Structured data is generally quantitative, measurable, or easily categorized, and relatively easy to store, query, search, and analyze using standard tools such as SQL. Examples are ubiquitous in business systems and includes customer records in a CRM, which includes names, addresses, phone numbers. Financial transaction logs, point of sale data, dates, and stock market. Unstructured data. In contrast, unstructured data lacks a predefined data model or organizational structure. It does not fit neatly into rows and columns and is often stored in its native format, frequently in large repositories known as data lakes. These categories include a vast array of information, often text-heavy or multimedia in nature, such as emails, social media posts, text documents, images, audio recordings, and video files. Sensor data and machine logs can also fall into this category. Unstructured data is typically qualitative and present significant challenges for searching, processing, and analysis, often requiring specialized tools and techniques like natural language processing for text or computer vision for images to extract meaningful information. Semi-structured data. It is also worth noting that the existing or existence of semi-structured data is also another aspect of categories of data, which falls between the two extremes. This data doesn't conform to the rigid structure or relational databases, but contains tags or markers to separate semantic elements and enforce hierarchies of records and fields. Common examples include data in JSON, that is JavaScript Object Notation, or XML, Extensible Markup Language formats, as well as emails, which contain unstructured content alongside structured metadata, which includes sender, recipient, and date. A critical point for aspiring data scientists is that while structured data provides easier entry point for analysis, a vast majority of data generated today is unstructured. Therefore, developing skills to handle and extract value from unstructured data is increasingly important for tackling complex real-world data science challenges. Data cleaning and preprocessing. Real-world data is rarely perfect. It is often described as messy. Data collected from various sources can be incomplete, contain errors, inconsistencies, information, irrelevant information, or duplicate entries. This process of identifying and correcting these issues is known as data cleaning, a crucial part of the broader data processing phase. The adage, Garbage in, garbage out, which is known as GIGO, strongly applies here. Feeding inaccurate or poorly prepared data into analytical models would inevitably lead to unreliable results and flawed conclusions. Consequently, data cleaning and preprocessing are fundamental steps, often consuming a significant portion of a data scientist's time, but they are essential for ensuring data quality, integrity, and the validity of any subsequent analysis. While specific techniques vary, the core conceptual steps involved in cleaning and preprocessing data typically include: number one, handling missing data. Data points can be missing for numerous reasons, which includes errors during collection, non-responses, or data simply not being available. Ignoring missing data is often not an option, as many algorithms cannot process incomplete datasets. Common approaches include deletion, that is, removing rows or columns that contains missing values. This is simple but should be done cautiously, as it can lead to significant loss of potentially valuable information. Imputation, filling in missing values with estimated ones. Simple methods involve using the mean, median, or mode of the respective column. More complex method might use predictive models to estimate the missing values. Imputation preserves data points, but introduces estimate values, which might affect analysis integrity. Understanding why data is missing, for example, completely random versus related to other variables, can help choose the best strategy. Secondly, removing duplicates. Duplicates record can arise especially when combining data from different sources or due to data entry errors. These duplicates can bias analysis. That is, for example, overrepresenting certain instances and should be typically identified and removed. Thirdly, fixing structural error. This involved correcting inconsistencies in the data structure or format. Examples include typos in categorical labels, inconsistent naming conventions, for example, USA, United States, US, incorrect capitalization or standardizing date formats. These errors can cause data points to be incorrectly categorized or analyzed if not addressed. Fourthly, handling outliers. Outliers are data points that lie significantly far from the majority of other data points. They can be caused by measurement errors, data entry mistakes, or represent genuine, albeit extreme, values in the data. It is crucial to investigate outliers to determine their validity. If an outlier is confirmed as an error, it might be removed or corrected. If it's a valid but extreme value, the analyst might choose to keep it but use statistical methods robust to outliers to analyze it separately. Number five, data transformation. Introduction. Sometimes data needs to be converted into a different format or scale to be suitable for specific analysis, techniques, or algorithms. This can include encoding categorical variables, for example, like red, blue, green, into numerical representation, or scaling or normalizing numerical features so they fall within a specific range, for example, 0 to 1, which can be important for algorithms sensitive to feature scales. It is vital to recognize that data cleaning is not merely a mechanical checklist. The appropriate methods depend heavily on the specific dataset, the context of data, and the goal of the analysis. It requires careful examination, critical thinking, and information judgment calls at each step to ensure the final dataset is both clean and representative. Introduction to tools: Python, Pandas, NumPy. To perform data manipulation, data cleaning, data analysis, and data modeling, data scientists rely on various software tools. In the Python ecosystem, a few libraries are foundational and widely used, particularly for handling structured data. A. Python. Python has emerged as a dominant programming language in the data science community. Its popularity stems from its relative simplicity and readability, making it accessible for beginners, combined with a vast collection of powerful libraries specifically designed for data analysis, scientific computing, visualization, and machine learning. It serves as the primary environment for tasks ranging from data preparation to building complex artificial intelligence models. B. NumPy, which is known as numerical Python. NumPy is a fundamental package for numerical computation in Python. Its core contribution is the int array, that is, n-dimensional array object, which provides an efficient way to store and operate on large data sets of numerical data, such as vectors and matrices. A key advantage of NumPy is its support for vectorized operations, which allows mathematical functions to be applied to entire arrays at once, rather than element by element in a loop. This leads to significantly faster execution speeds compared to standard Python lists, making it crucial for performance intensive calculation, common in data analysis and machine learning. Pandas. Built upon the foundation of NumPy, Pandas is the primary library for data manipulation and analysis of structured data in Python. It introduces two essential data structures: the series, which represents a single column of data, and data frame, which represents a two-dimensional table with rows and columns, akin to a spreadsheet or SQL table. Pandas provide extensive functionality for reading data from various formats like the CSV files, Excel spreadsheets, SQL databases. Cleaning data, handling missing values, filtering goals. Transforming data, which includes handling columns, reshaping tables, merging data sets, and performing exploratory analysis. Its intuitive structure makes working with tabular data much more manageable. For beginners, the focus should be on understanding the purpose of these tools within the data science workflow. Python as the language environment, NumPy for efficient numerical operations on arrays, and Pandas for versatile manipulation of table data. These libraries often work together, forming a core part of the Python data science toolkit. Mastering the basic usages fundamental steps towards practical data analysis. Below are recommended resources for further learning in Module 2. In conclusion, data science exists in structured, organized, and tabular, and unstructured, which include lacking predefined format or fonts. Raw data is often messy, necessitating crucial cleaning and pre-processing steps, like handling missing values, duplicates, and outliers to ensure quality. Python, along with libraries like NumPy for numerical efficiency and Pandas for tabular data, are fundamental tools. We've come to the end of the Module 2 of this data science course, where we learned about data collection and processing under the following units: data sources, which includes structured and unstructured data, data cleaning and preprocessing, and introduction to tools such as Pandas, Python, and NumPy. In the next module, we will be delving into exploratory data analysis.
Thanks. Alright, we'll be taking a look at functions in Python. So a function is a block of code which one is only run when you call it. So there's a way to define functions. So right here is a way to define function. And so right here we're defining our function, and this is a body of code that when we actually call it, it will run. So right here we have our function call. How we are doing is put in the function with parentheses. That is basically calling out that function, like we calling that function, right? And then we have our output. So we're going to be showing you how to write a function as well as pass argument in this after aspect of the video. So how to pass argument to our function, and then a few other things like arbitrary arguments, keyword arguments, and arbitrary keywords. All these things are really important to know when you're using the functions. So let's get started by writing our very first function together. We're going to start off by saying df, which is a keyword defined in function. Then we can actually name our function. So for this, we're just going to do first underscore function, right? Then we'll do an open parenthesis. So put a color and hit enter. Sorry, to all of hits. Sorry, enter. Now, the mistake I made is hit in shift enter. Now, you're not supposed to hit shift enter. It will bring up a syntax error, right? So let's do this again. So start it now. Go that. Now, you're supposed to just hit enter, which automatically index or rather intent for us. And that is where our body of code is going to go. Now, within our body of code, we can write just about anything. And in this video, we're not going to be doing any advanced stuff. We're just going to walk through basics to make sure that you understand how to use functions. So right now, what we're going to be saying is just straight. You open your parentheses. Then we'll do an apostrophe. And then we say, we did it. And now we're going to be hitting shift enter. Now, it's not going to do anything. At least you won't see any output from this. But if you want to see the output, or we actually want to run that function, and some functions don't have outputs. But if we want to run that function, what we have to do is just to copy this. Put it back here. And we're actually going to call our function. So let's go ahead and click shift enter. And now we've successfully called our first function. This function is about as simple as it could possibly be, as simple as it could possibly be. But now let's take it up a little bit up a notch. Let's start looking at arguments. So let's go right down here. We're going to say, so find number square. We'll do parentheses and a colon as well. The colon as semicolon. Okay. Now, really quickly, when you're naming your function, it's kind of naming a variable you can use, something like x, y, but it should be try to make it more descriptive, right? So let's take a look at passing an argument into your function. the argument is going to be passed in the parentheses. So for us, we're going to call it number. We're going to hit enter, and now we'll write our body of code. So what we're going to do for this type of range, and open parenthesis, I would say number, sorry there, number, do the 2 stars. Okay. Now, what this is going to do is that it's going to take the number that we pass into our function. It's going to put it right there in our body of code. And then from what we're doing, it's going to put it to the power of 2. So when the user or you or anyone run this and call this function, this number here, it's something that can look as specified. It's an argument that you can impute that will then be run in this body of code. So let's copy this right here. You pull it right out here into the snapshot. And then we say by so this file is going to pass through into this function and be called right here for this track step length. Let's run it. It could come out as 25. Now, this is my code. I forget to actually run in the block of code. So then it's I'm gonna hit enter. Okay, now we define our function obligation where we didn't define it actually before. And now we can actually call it so. Now we'll hit shift enter. Okay. Now what comes now? We have to look through it for any issue. Don't be scared of errors or syntax errors as it is. Just look through what you haven't included or added. So it hasn't run, hit enter, number, square, 5, okay, leg it off, and we have 25. If it's well, semicolon. Just read through every error so you can have a very viable output, which is for this case is 25. Now, in this function, we only called one argument, but you can basically call as many arguments as you want. You just have to separate them by comments. So let's copy this and put it right down here. Now we say number squared underscore cost. And the new number, right, we have the value to power. And now we can specify our lower as well as the power we want to raise it to. So instead of adding Q, which is what you call accolade, we can now customize that and we'll have power, and then we call this function, we can specify, okay, so we'll have a specific amount of power. So what we call this function, we can specify the number and the power, and both of those we go into this button level. And we route and we customize those numbers. So let's copy that. Can I move this 5 to the power of 3? right? So let's look for, we actually run this shift enter, right? Now we can call our function this, you could shift enter. And we've got 5 to power 3, which is 125. And just one more last thing to mention is, if you have 2 arguments within your functions, I call it a right here, you have to pass a 2 argument. You can just add 1. So if you have a 5 right here, it's going to be error. So for example, third part is extract 100. Sorry, that's going to be an error. We have to specify both arguments here to work. So let's add 3. You have 1 to our part. So let's take a look at arbitrary arguments. Now, arbitrary arguments are quite interesting because you don't know how many arguments you want to pass through. If you don't know if it's 1 or 2 or 3, you just specify that later when you call in the argument. So you don't have to do it up front and know that information ahead of time. So let's define our function. Okay, let me add more cells to this. So just say define. Say number underscore ads. It will do an open parenthesis and a column. Within our argument right here, typically we just specify here what argument will be. It will be number or it will be a word. We're going to be doing something called an arbitrary argument. So it's unknown. So we're going to put star. Star, we're going to take fact. Now, you will see something exactly like this. Typically, if you're looking at tutorials, they'll add star arcs in there, or if you're looking for just a generic piece of code, this is what it will look like. But for us, we're going to actually put number. So again, we have the star, and then we have our arbitrary argument right here. Then we hit enter, or maybe you could say blank, open parentheses. So then we're going to get a little bit different. We're going to take number from bracket and say 0 and say times. Okay. I'm going to do that times. Save it per project. So when we run this and then we call this number x function right here, we're going to need to function right here. We're going to need to specify the number 0 and the number 1 that's going to be called. Go ahead and run that. And we'd like to call it, let's say 5, x, 1, 2, 8. So right up here, we know how many arguments we're going to pass through. It could be 5, it could be 1,000. We could also call in a kickoff, and that's what it is right here, calling the people. So what it's going to be now is when it called this number, it's going to call the very first within that tuple, which would be that 5. And then it will also call this number. we revert the first position, which is the 6. Left 8, 2. So it's going to multiply these numbers together as 5 times 6, which is equals to 30. Now, like I just said, this is a triple. So this is a triple. So we don't actually have to write out these numbers like we just did. We then pass through a triple where we actually calling this function. So let's do that right out here. And just create X. X in this country. Few open parentheses. Just just copy it from here to make it easier. Now produce before right here, which we can then pass in. They'll be a lot more handy, a lot more specific, and this is most likely how somebody do something like that. But let's now create that. Now can copy X to Paul. And pass through. So just so you know, let's do a fail. It's on purpose, but when to show you so you know what you need to do in order to pass through this tuple. So that's why, right? So right now it's the other say, sorry, Google index and all of that is algorithmic, but it says our triple is not defined, right? But in order to use this, you have to specify a term for it. Just like you did while we're creating your argument up here. The algorithm start in front of our triple that we just passed. Now let's run it again. Fine. Why do you still have that? Okay. Number heads. So why do we still have error? So remember here we have only going this. So you run it, shift, enter. So when you come back here now you just enter. And now it works properly. So that will be all for the functions in Python, which we can still look at in the future videos, keyword arguments and arbitrary keyword arguments. But let's check that now. Yeah, let's check that now. So in the other videos, we're going to advanced learners. So there are more things you can learn or do within the functions, but again, just to learn the basics, make sure you ultimately understand how they work. So let's go wrap up here. So a keyword argument is kind of similar to this wrap up here. Wait a moment. So let's cover this. Now, keyword is right. Okay, keyword is very similar in that you're going to specify your arguments right here. What we in over here. Oh. So when I move it up here, is this house. So we'll actually call the function. What we did was to just put it 5 and a 3. And we'll see that it automatically assign the number 5 and the power of 3. And that's totally okay. You can do that. But if you want a little bit more control, you can use a keyword argument. So right here, we could say r is equal to 5, a number is equal to 3. So I just switched it around. Right number was assigned to 5 and the power was assigned for 3. I just switched it to show you how this might work. So let's run both of these. Notice. So we have an error again. So what could be the concern? Now, what could be the concern? Because I did that. So let's do that again. So this is actually case sensitive. Remember in the beginning video, we mentioned that this can be quite case sensitive. So my keywords and cultural error. Let's run it to see if there'll be another error again. Right? Yeah, you cannot expect a keyword argument. We're going to put it back to where it was. So let's run it again. And now it's 3 to the power of 5, which is 243. That's 243. So that essentially is a keyword argument. Again, it just gives you a little bit more control. You don't have to put that in specific positions, like you just calling multiple arguments. So let's go down right here. That's our motels. We'll go right here. We're going to create basically another cost of control. So for this one, we're going to write define number underscore quag. It's parenthesis and a colon, hit enter. Now this was the keyword argument or an arbitrary keyword argument. Now to specify an arbitrary argument, all we did was our parent and then we impute no. But if you're doing a keyword argument, we actually have to add 2 stars right before we impute number. So right here, 2 stars. Okay, but you indented, but it didn't. Something is wrong. So you just make column, not a column. Now, these errors that you kept seeing and I keep correcting are the feasible and possible errors you encounter alongside errors like the case sensitivity, the colon, semicolon instead of semicolon, colon, all those little colons, using a semicolon instead of a colon, right? Now, clicking enter on this will automatically indent this for you, right? Now, let's start taking a look again. And if you're doing arbitrary, it means we didn't really know how many keywords argument we want to pass into our function. So we're just going to put that's the number and the letter with our body of code. And when we call it, we'll be able to specify. It's just like the arbitrary argument before the arbitrary keyword argument means we really just don't know how many keywords argument we're going to need to pass into our functions. So to demonstrate this, let's write print. We can create this. We say my sorry, I'm supposed to do an apostrophe. Straight. I do guess. So when I do that, let's say face, I'm gonna just plus, spec plus. So this way it gets a little interesting or a bit more tricky. So we're gonna say is number. This semicolon is supposed to be here. Supposed to be here. So plus number So this is us calling our number, and then we're going to do a bracket. And then we're going to go to calling the function. It's a little bit backward. Or a little bit different than what you might think. But what we are calling it, what we're going to do is we're going to say integer sequence express random number, right? So what we're calling that keyword within a body of code, what we're going to do, what we're going to do is we're going to actually type up integer. Just like this. This is a little bit different, but what this allows us to do is we can put as many keyword arguments in here as we want. We'll show that later. Okay. For us, we just create in this key and this value when we're calling it within the function. So now, what we create is when we run this, most likely do the error. What will this? Yeah, we have an error. You know why? This is supposed to be in the trend. So let's run it again. Like I said, every error is assigned to show you what you can do wrong and how best to do it. So let's try it again. Obviously having that. Obviously having error. So what did we do now? So it's not defined. So it means I will run that here. So let's run it. Now we're right here. Now let's run this again. Let's go through now. Right? Now we'll say my number is 309. We're gonna add us. Now it does not make it look great, but let's say my other number. Okay. Alright. Okay. So right. Okay, that's okay. My other number that will say number. And we specify again what we want in there. So you can go down here to where we're calling it. We could say integer is equals to another random number. Yeah. So we had the plus right here. So we want another here. So to create this, remember this number. So we right, we created posts. Well, we run with it. Now, see both numbers pass through, right? In case the syntax is terrible, but now you can see that you have this arbitrary keyword argument right here, and all we have to do is put number, And we can pass through as many of these arbitrary keyword arguments as we want. And I'm not if we just specify it within our component or recurrent. Okay, so that's all we're going to look at today's explanation of functions. There are other things that you can do with functions, and they can get a little bit more advanced, but we're just going to show you that this is just an introduction to these basic functions. Thank you
for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.